Okay, starting on the bottom half of the worksheet, I kind of gonna sneak this cheat sheet in here so we can use that to our advantage here. So starting at number 7, this is a single replacement reaction. It says single replacement, so it's already labeled for you. We're going to be down here on your cheat sheet for single replacement. And when you do a single replacement reaction, you need to write it out in symbols first. So aluminum is going to be Al, and aluminum is not diatomic. Sulfuric acid is going to be hydrogen bonded with sulfate. And sulfate has a -2 charge, so I need to balance those charges. And now when you get to the single replacement reaction, the most common mistake students will make is who is trying to replace who? Aluminum, is it trying to replace the hydrogen, the H2, or is aluminum trying to replace the sulfate, the SO4? The easiest way to answer that question is aluminum is a cation. It has a +3 charge in the periodic table. Therefore, it's going to try to replace the cation or the positive charge in the compound. If the element that was alone is negative, for example, number 8, chlorine is -1, it's going to replace the negative charge in the compound, which is iodide. So you just got to look at what's alone to determine what it's going to replace. So the alone element here is aluminum. It's a positive charge. So hydrogen is +1, SO4 is -2. So aluminum is going to replace hydrogen. Like charges will replace each other. Cations replace cations, anions replace anions. So in this case, aluminum is going to replace the hydrogen. So if we look over here in the products, hydrogen is going to be all alone. And remember, hydrogen is diatomic, so we're going to put H2 there. The new compound is going to be aluminum and sulfate. They are going to bond. Aluminum and sulfate will bond together. Remember, aluminum has a +3 charge. Sulfate has a -2 charge. So we have to put subscripts accordingly to balance those charges out. So all the subscripts are done with. I just have to add coefficients where necessary. Over here we have 2 aluminums because it's Al2, so I'm going to put a 2 out in front of here to balance the aluminums. The hydrogens, H2, we have 2 here, and over here we have 2, so right now the hydrogens are good. I would treat the SO4s as an entire quantity. So I would say, how many SO4s do I have here? 1. How many SO4s do I have here? 3. How do I get 3 sulfates? I need to put a 3 in front of there. So I treated the SO4 as a quantity together. There's 1 SO4, here there's 3, so that's why I put a 3 out in front. When I did put that 3 out in front, however, I changed the amount of hydrogens from 2 to 3 times 2, which is 6. Can I get 6 over here? Yes, I can. I just need to put a 3 coefficient in front of the H2. So now the coefficients are 2, 3, 1, 3, and everything is balanced. So those are single replacement reactions. You'll start with an element in a compound, and you will end with an element in a compound. And to determine who's replacing who, remember the anion will replace the anion, and this is a cation, iron is positive, it's going to replace the copper in this next one. So I'll give you a little hint there of who determines who's replacing who. On your cheat sheet, there's a lot of other things that goes on there, but for now, don't worry about this. Just have it replace the correct element, and you'll be all set. Since we're not in class, I don't want to confuse you too much. Just replace them. Double replacement reactions. Getting down there at number 10. Silver nitrate. Silver nitrate is going to be AgNO3. Silver's +1, nitrate's -1, so those are good. Zinc chloride. Zinc normally carries a +2 charge. Chlorine's a -1 charge. So we have 2 compounds and a double replacement reaction. These are 2 couples, and we are going to do a wife swap. So we're going to take the 2 cations, silver and zinc, and I'm going to switch their spots. So the NO3 and the Cl are going to stay put. So instead of silver nitrate, I am now going to have zinc nitrate as the first compound. And remember, zinc carries a +2 charge. And instead of zinc chloride, I'm now going to have silver chloride, which is going to be AgCl. And now I just need to balance it with coefficients. I have 1 Ag here, and I have just 1 Ag over there. So far silvers are good. NO3s, I have 1. Over here I have 2. So to get 2 nitrates, I'm going to put 2 out in front. I do now have 2 silvers. So I'm going to go ahead and put a 2 over here to make my silvers balanced. Zinc, Zn, I have 1. Over here I have 1, so that looks good. Chlorines, I have 2. Over here I have Cl2, so I'm good there. So everything looks balanced other than those silver and nitrate, but I got everything balanced now. So we're going to just go ahead and put 1s in front of those since everything's balanced. Down here for combustion reactions, the bottom one. Combustion reactions, methane is going to be CH4, O2. And if you look at your cheat sheet for combustion reactions here, it's always going to be CO2 and H2O as a product, every time. So therefore, we're going to go ahead and write CO2 and H2O as the product. And we just need to balance it. 1 carbon, 1 carbon. 4 hydrogen, 2 hydrogen, so I'm going to put 2 there. So 2 times 2 is 4. Oxygen, I have 2. Over here I have 2 here, and another 2 here, so a total of 4. So it's going to become a 2 there. And that'll be 1, 2, 1, 2 to balance those. These oxygens add together. So this is O2, and this is another 2. So there's a total of 4 oxygens over here. And 2 times 2 gives me 4 in the reactant. So everything's there. So this worksheet's going to take a while. Ask questions. I'm going to post the answer key on Friday after you guys turned it in and tried. And I'm not going to be giving you credit for right or wrong. I'm just going to be giving you credit for attempting it first and then looking at the answer key and making your corrections. So if you want points for this, at least attempt it before Friday and turn it in, and then we can make corrections later.